Hey, Marko, how are you? Hi, James.
Hey, good morning.
How are you doing today?
Hey, not too bad. Not too bad.
Well, that's good.
It's great to be here. Sorry I couldn't attend much of them previously due to class. I had class problems.
That is, well, I understand that, and I certainly appreciate that. I know instructing is a lot of work.
Yeah, no worries. Glad to be here. Thank you.
No. Hey, Mirjana. Hey, Marko.
Hey, hi, hello, everybody.
Hi, hello.
There's Mehdi.
Hello.
Hey, Mehdi.
Hi, Rob. How are you?
Hey, Maddie.
Hey, James. How are you doing?
I'm doing great.
Yeah,
Great to see you.
Yeah, same here. Just met with John last week.
Yes, sounds cool.
Yep.
I appreciate that.
Yeah, no worries. That was cool. Hey, Marko, Mirjana.
I'm Eddie.
Hello.
How are you guys doing?
We're good. We're good.
Awesome.
Hey, I'm really scared to share my camera. I'm actually in my office at home. That is at the moment, everything from the cellar that should be there, that is still not ready, is here. So let me, before everybody joins, let me do a simple small test.
Smoke test.
Oh my God. Okay, smoke test. Yeah.
It looks fine.
Choose
great,
virtual
actually.
background. Yeah.
What's
I'm doing, because it is kind of, let me see, download. Because I'm
Looks better than
pointing
mine.
upwards, there is nothing there. Yeah. But Marko knows it's, work in progress.
Oh, is this a new office you have?
No, I actually moved. I bought a flat, so I moved last month.
Oh, okay.
But yeah, nothing is kind of where it should be.
It's gonna get there, I'm sure.
Yeah, well, it has to one day. Let me
Hi,
see,
here's
I'm
Christoph.
trying.
Hey, Christoph.
Hey, hi,
Hey,
Hi,
Christoph.
Christoph.
We'll wait a couple minutes because I do expect more folks to join us. And we did, Marko, Mirjana, I did get a number of folks interested in the meeting from the posting I did on LinkedIn under Chips Alliance. So I thought that was good.
Okay, cool.
Good.
We had already a dry test, during our regular Monday meeting.
Oh, you did?
So, yeah. It's actually interesting. More people are kind of finding us. I think this LinkedIn posts help. So, I mean, more people who are doing similar things with generators. So I'm kind of optimistic that, especially with this initiative that we're having right now, and Marko and me are part of it, Christoph also, that will hopefully break the ice, and create a critical mass of people.
Yeah, I think you're getting to that point. And like I said, I was pleasantly surprised, at the interest that I got on LinkedIn, which thanks, Marko, for suggesting, trying to get some additional socialization for this. So I think that's great. And I think with that, we've got about 12, 15 people here right now. Excuse my dog barking if you can hear him. But anyway, so welcome everybody. I want to thank everyone for coming today for the analog work group meeting. And we covered a number of different topics, including different collaboration project ideas, and also looking at improving automation in the analog space, which of course is always a challenging arena. And today we're going to have an update on programmatic analog IC design that Marko, Kusunen, and Mirjana is going to update us lot of Mosic is going to update us on today and the work that they have been championing and help to try to move the community forward on that area. So with that, why don't I turn over to you, Marko and Mirjana?
Thank you, Rob. So Mirjana, should I start or do you want to go say something before we
Yeah.
go?
Marko is actually, let's say, brains behind the idea. I'm the muscle to clean the technology and to test it. So Marko.
Okay, thank you. So I will share my screen. As I mentioned, I don't have any slides. I will just describe the structure of the project and explain what's going on there, and hopefully you get an idea how we have organized things. So I assume that you see my web browser at the moment.
Yes, Marko, we're seeing it. Please go
Yeah,
ahead.
okay, good.
Yeah, we got it.
Yeah, so I'm in a GitLab in the group Mosaic Bag. This is like the main group for this our fork of Berkeley Analog Generator and like template environment to use it in a relatively efficient manner. There is one main project under this group which is called Virtuoso Template, and there is also an automatic continuous integration build of documentation of this project, containing online documentation of all the submodules or the main submodules in it. And I'll briefly show you the documentation. This is automatically built every time we push to the latest development branch. So it has certain some introductory text and describes all the modules what we have there. Of course, this documentation is not complete at the moment. We will amend it as time passes. But anyway, this is a start, and I think this is quite important in order to get everyone in and interested and lower the threshold to get this thing into use. So as this is open source project, what we decided with Mirjana at quite early phase is that we should have a kind of a well-structured development plan or release schedule for this. So I wrote a brief developer's guide for this environment. And we decided that we have two release dates per year, 4th of 4th and 10th of 10th. They are easy to remember. And then some instructions about branching and how to do merge requests for these releases and so forth. But I think this is kind of the backbone of the development. So if anyone of you tries the environment, finds something that needs to be improved, feel free to file in a merge request, and we or someone will check that out. And if it's okay, we will merge it. If there are some feedback, then we will provide the feedback, and eventually we will converge to the better environment. But anyway, I think this documentation is at least this good starting point for the things forward on the coming years, I hope. So then I will go briefly through the structure of this Virtuoso template itself. So as said, this is the main project, and it can be found here. And the aim of this template, I go to the latest release candidate branch, so you can see what is the current status. The aim of this template is that we provide a set of shell scripts that you can easily use to take this environment into use. We have pip installation script to install all the Python dependencies you need to run this environment. We have init submodules that initializes all the Git submodules in this project, so you don't need to worry about what to initialize and how it will do it for you. We have README file, of course, licensing. And then we have two source.me scripts. One is for C shell and derivatives, and one is for bash. And basically, this source.me script, Mirjana will later on show you how it works, but it forces you to set things up correctly. So basically, you start in all of you have in your organization certain set of scripts to set up a Virtuoso environment for certain PDK. And after you have done that, you source this script, and it will tell you that, okay, you should point out your technology installation directory with this environment like variable and so forth. And you should have these files configured so that we can run Berkeley analog generator in this environment and so forth. And once you are done, it says that, okay, now we're done, you're good to go, and you can go to run your first generator, which is in this case minimum working example of an inverter called Inverter Gen. And you can go there. I'll just briefly show what it has. So it has a configure script. You run /configure and make gen, and it will generate the layout and schematic of this inverter for you. So it's really a minimum working example that just shows that your environment has been set up correctly and it works, and you can start extending this inverter generator, or you can generate we have a shell script that you can use to generate a new generator template, which is actually, it has a functionality of inverter, but it's easy to start modifying it for your needs. So
Hey, Marko, can I ask a question?
sure, yes.
Yeah, I'm just curious. Does this create the primitive schematic and layout in open access, or is it through hooks into Virtuoso, which then of course eventually goes to open access? But I'm just kind of curious how the mechanics of that work.
This works with hooks in Virtuoso because open access to open access is not actually open. So
Yeah, I know. I'm familiar with that problem. Yeah.
Yeah, so this is using Virtuoso skill interface to Virtuoso. But if your organization has access to open access, basically what we use, if I go back there, let's see. So if I go now outside the Inverter Gen, we use these back framework bag templates. They are actually the back framework, back two frameworks from UC Berkeley. So they support open access through some interface layer called SciBag OA, but you can't build that without access to these open access C headers, and we don't, so we haven't tried that, but in theory it's possible.
I see. Okay. All right. Thank you.
So we haven't hacked yet any of these like UC Berkeley generated back frameworks. There are some proposals how to develop them further, but we haven't done that or touched them yet, just to maintain compatibility at this stage of the development. So I briefly go through what we have here. Back to environment settings, it's basically collection of scripts that are common for all the back environments. So we store them in the one submodule in order to be able to propagate the changes effectively to any of the projects using this framework. So you can just update the submodule if you need to get updates for those setting files. Then we have back to framework that I said already. It's just a fork from UC Berkeley. Back to templates. This is basically a submodule that contains analog base and certain examples, also forked from UC Berkeley GitHub side. And back to technology template. This is new production. It's a collection of abstract Python classes that tells you all the properties that are needed to define a process parameters for this environment. So let me go back to this release candidate so I can show you the latest version of this. So if I go through this back to technology templates, it contains Okay, if I go back first. So basically, this template is something that you can fork and start building your technology definition on this template. There are instructions how to do this. So if I show you the main class, it tells you that, okay, to use this as a back technology definition class, comment the following lines and then uncomment the following lines and so forth. So you can convert this from actual template to actual definition. And then what you then need to do, you need to figure out the process parameters. And those are collected mainly these sub-modules, layer parameters, most parameters, resistor parameters, and via parameters. And these are just abstract properties that define the properties that we use in the technology. So as these are now properties, instead of like entries in a YAML file, we can use doc strings to document the purpose of these properties, which is relatively handy. Unfortunately, we just, for many of these parameters, we actually don't know their actual function or how they really affect your layout. Some of them are clear, some of them are less clear, but we have working examples that we have converted to this format, and we have, through that conversion process, we have been able to generate a functional template for a process definition, which is now configured for Cadence CDS FFmpeg process. So you can also use that as a example how to set this up. The reason why we use this is that when we introduce a new parameter, we can introduce it as an abstract property, and then your actual technology definition inherits this class, this template class. And because this is an abstract method, it forces you to redefine this. So in your process definition, which I show next, you must define values for these parameters. And so I hope that the idea of this technology template is now kind of clear. It defines what you need to define. And then what you define is in this back to technology definition that actually looks quite the same in the structure than this template. There are only some strings changed to another, but we have here this main back to technology definition class. It has a property process config that has all these process variables or process parameters stored into it, and values of those parameters are defined. For example, in this layer parameters.py, which inherits the layer parameters template. So this template tells what you need to define, and here we have defined all the parameters that we must overload in this class. So for example, this says that the name of the technology library is CDS FFmpeg. Layout units are 1 micron. Layout resolution is 1,000th of micron, meaning 1 nanometer. Some
Hey,
other
Marko.
parameters. Yep. Okay.
I started to trouble you with another question, but no,
Sure.
this is good. You know, the underlying understanding required here, of course, is being able, you know, basically understanding how to do abstract-based programming, or, you know, in other words, class-based programming, like in, you know, what was originally seen in C++ or in Objective-C, you know, years back. I just was curious relative to what are your guys' thoughts in terms of, you know, layout or circuit design engineers understanding this and taking it forward. I'm not saying that they cannot, right? But I think it's a necessary evolution of skill set, but it's obviously very different thinking than what many have originally learned. So just curious what the experience has been so far in that. If you can't say it, that's okay. Go ahead, sorry.
This is a very good question. I would say I'm 48 and I was able to do it. But okay, circuit designers, I would say that if you think of bigger organization where your circuit designers remain as circuit designers, they still need to know the basics of object-oriented programming.
Okay.
Configuring this framework, configuring these processes in a larger organization, I would leave those for like technology PDK support personnel, which should be relatively fluent with Python. But it's
Right.
easy to, it's possible to write the generators without advanced knowledge in programming. It's also possible to maintain these processes without any like very special information about programming. Just basic concepts are enough. But if you are strictly in analog design, strictly in schematic entry, strictly in manual layout drawing, there is certain learning curve ahead.
Okay.
Yeah.
May I comment here? So
Yep.
what I've seen is that young design engineers, circuit designers, they are open for doing this. Not all of them, but many or some of them. What is more tricky is to convince layout people because they like to do graphic user interfaces, and it's obvious that doing layout is a very graphical thing. So these people are more reluctant to switch, and there's a good reason, I believe. So, but this is also a good opportunity to think about adding tools on top that provide such graphical interfaces.
Yeah. May I also comment here, Rob?
Yeah.
What I believe is that, with our joint effort and especially open source community, we need to create a new, let's say, breed of engineers.
Mm-hmm.
Where automation reuse goes hand in hand with IC design, and there is no question about it. So how can we do it? Only by, putting something together and making this onboarding process for people who wants to join, and for the new curricula, etc., making it easier. And like Christoph said, I also seen, in our organization, very experienced designers. They're very reluctant. That is like mild way to say, but I believe that the young students just went from the university. They are much more kind of susceptible to new methods, and basically they should be at this stage maybe our target group. Yeah, thanks.
No, thanks for both for the comments. No, I agree with that. I was not trying to start an insurrection here, I guess, with my question, but mostly just basically just based upon my own experience working with analog folks over the years, and I think in terms of as Boris and I have chatted, Mehdi and I have chatted, chatted with Bora as well and others, right? That we certainly need to look at improving the overall productivity and reproducibility of results, and automation certainly helps doing that, and also aids in terms of technology migration as well. And I think embracing more modern concepts in terms of how we can do things in design is important, and it also will help us attract newer students, right? And enabling different ways of thinking. So thank you.
Rob, I would like to say maybe only after Marko finishes and we finish with this demonstration about the plans, after this, let's say first effort that we put in. But let's Marko continue maybe with
okay.
I do have a couple of questions for you guys. So I saw the post from Bora, who's using Backtree to do SAR ADC. So how is this framework different from Backtree, and what is the differences, if you may help me understand?
Yes, this is based on Back2, which is like predecessor of Backtree, and the reason we're using this is that both me and Mirjana, we have experience on using Back2, or more experience on using Back2, and to my understanding, Backtree is actually not as open as this is. So I would say that it's easier to, in the future, if seen feasible, it's easier to migrate from this to Backtree, but start developing the needed skill set and start cleaning up this environment with Back2.
I see. So, are you
Yeah.
saying Backtree is relying on some? Go ahead, Mirjana.
So I think, Dan, you can correct me, but when I was comparing, I never worked with Backtree. There are like a couple differences. The major is that Backtree does not use, let's say, skill and let's say skill procedures to execute something, in Virtuoso, but does it directly under the hood with C++. And
So
you can see
that's Backtree. Sorry.
that's Backtree. That's Backtree.
Okay.
So I think if you see, like, just compare start_back.il in Back2 and Back3, and you can see that a lot of things are just gone.
I see.
And so that exactly part cannot be, because of this SI2 limitations, cannot be let's say open source cannot be shared. And I think that is the major obstacle of spreading Back3 in performance. Bora is saying like it's 10 times faster in simulation, which is expected, and execution, which is also expected. And they kind of figured out that Back2 has a limitation when they have been designing bigger SoCs. But maybe Dan, you can add something. I saw you in the list.
Okay. Cool. I still not sure why Backtree is more closed source than Back2. Since Backtree is using skill, based on my understanding here.
Sorry, my audio is not working. Can you guys hear me now?
Yep.
Yes.
Yeah. What Mirjana said is more or less right. At least as far as why you wouldn't want to make that upgrade is it primarily jumps from Python code that manipulates Virtuoso to Python code that manipulates open access and Vector directly. I'd say that's half of like the major goals of the change. The other half is kind of production of all of the other stuff that goes with an analog IP. So production of Verilog models, production of timing models, and the like. And I would say much of the work went into that. And yeah, a lot of the shift to directly using AWG C++ API was based on having sufficiently large generators that going through that Python to skill loop really did turn into like many hour or even many day runtimes. So I think you've got the idea quite well in hand.
Yeah, if I may add just one more thing, for instance, in Back2 we use analog base, and there is digital base, which is kind of additional methods, a bit more flexibility. But if I remember correctly, Back3 uses mass base. So it was like iteration and change, and they, in my opinion, they figure it out, and as they go, they change, the methods, trying to, how to say, optimize the scripting of the layout. Mm-hmm. Because at the end of the day, scripting of the layout is extremely manual process. And I will say something about it at the end, not directly to this. Yeah, thanks.
Yeah, I would say that's probably even more true than you said. There's more kind of programming model changes to how layout gets constructed and such. And just reaching back to how can you convince people to write a layout as a program rather than draw it in a GUI. I don't think that the answer of they can code, therefore they can code a layout really cuts it. And we have plenty of experience of that attitude really failing. I think it really does boil down to just what is the mental model and what is kind of the interface, what are the ideas that the library injects to help someone program one of these layouts. And there are lots of trade-offs in how detailed they are versus how accessible they are. And I think this has generally drawn a very detailed line that has had a pretty niche set of people be able to latch onto.
Cool. So so basically it is a way of drawing layout using coding or software, And are you guys planning to have like a GUI to see interactively how your code is changing your layout, or do you have to compile and then go check the GDS and see what's happening? Like, what is the process?
We show the process in the end of this presentation.
Okay, cool.
Mirjana shows it. So okay. Yeah, these are valid remarks of my comparison of back 3 and back 2, and they're highly evaluated. On my side, I can say that I tried to construct something that gives lowest possible threshold to get your hands on in generating layouts and schematics through Python, because that's already quite a huge step for at least our students in the university that I'm working. And for that reason also, we have kept simulations and even DRC and LVS checking out of the scope at the moment. So we know that in every organization, you want to do it in your own way. So what we provide is the way to programmatically control your schematics and layouts. If you want to simulate them, you can generate, of course, the netlist and pass it to the simulation environment, but it's kind of up to you how you want to do it. For example, in Aalto University, we use something that is called the Sidekick, which is a Python interface for various analog simulations. And we can just run these generators inside that environment, but it doesn't necessarily interest you, so we kept it out of this environment totally. And focused on these technology definitions, which is the pain point, and then also like clearing out the structure of the generator so that it's as clear as possible, so that every file has their predefined location. All the generators have the same structure, and you can use them inside each other. So that's the main goal. It was available in back 2, but we clean it up a bit, and that's where I'm going next. So this was the principle of the process definitions. You probably got the idea. And then let's go to this, back to this Virtuoso template. So idea is that every generator is a Git submodule inside this project. This is just a project template, but if you fork this and push it to the other repository, it becomes your project. And you can add generators as a Git submodule, so they will live here in parallel with this Inverter Gen. And in this main project, we have a configure file. When you run it, it will create a make recipe for all of your generators. So if I want to run all the generators inside this project, I just write make gen, and it will go through all the generators, run them one by one. If I want to run only one generator, I can give make gen Inverter Gen, and it will run the generator also only for Inverter Gen. So this is kind of a top level control of generators. I don't take at this point any stand on how you pass the parameters to those generators. You can do that in various ways. We will show you one. So if we go to this Inverter Gen, you can also run all these generators independently. Every generator has the same structure. It has a configure file. When you run the configure, it will create a make file, and then from that make file, you can run make gen, and it will run the generator. And this idea of using the same structure over and over is copied from kind of Linux environments. Everyone who has installed Linux programs from source, you can do that without reading even the README, because most often it goes that you write configure make install, and it will install the software for you. If that doesn't work, then you need to read actually the README. So if you keep the structure constant, follow certain policy, you don't need to document it. There is no variation. Every generator runs in the same way. And also the structure of the generator, all of the generator is the same. We have templates. So the name of this circuit that we are generating is inverter. The name of this generator is Inverter Gen, and it has a directory with the same name. So all the Python lives here, and the templates, schematic templates for this inverter, they live here, called inverter templates. If you have op-amp, this would be op-amp templates. If you have SAR-DAC, this would be SAR-DAC templates. Sorry, SAR ADC template. And what is inside this directory for the Python code, there is the master file for the class, main class definition, and there is 2 modules, layout and schematic. Now you can guess what goes where. So this is the schematic generator, this is the layout generator. And this is the main class. So what it has an init method, and all the parameters needed to generate the layout are documented properties. You can, if you want, create a method so that you can pass these properties, for example, from the YAML file, or you can use this inverter inside another generator and pass these parameters from the higher level of your design to the lower level. So you can automate this parameter pass as you wish. This is just Python. We can, of course, in the further development also figure out ways how to automate this parameter propagation throughout the hierarchy. But what we wanted is an environment where you can use doc strings to document your actual parameters and what they do. And in every generator, you have this main guard, which actually defines what you do. So the generation process has now been condensed to the 3 lines of code. And this is the basic structure, and this is enabled with 1 additional helper class, which is in, actually I will show this latest development branch also. So what I added here as a last fix was the argument parser from the command line. So you can pass certain simple control parameters from the command line to this generator, which makes it possible to actually have like different make recipes for, let's say, FinFET flavor, Flipwell flavor, and pure CMOS flavor of this generator. So you have a great flexibility to control these generators, but the structure is very simple. The locations and names of the files are like given to you, just fill in the blanks and you are good to go. And then I hope that I didn't forget anything. Yeah. So what makes this possible is kind of a wrapper class. So back to as it was used in, for example, in examples of UZB, the structure where the schematic generators lived and where the layout generators, where it was a bit how to say scattered. So I wrote, or me and my students wrote a helper class called backECD, which pushes under the hood all this code that needs to be executed every time you create a back generator. So basically we created a class called backDesign, and it has a init method and certain methods that are executed when you actually instantiate this generator. And basically what it does, it imports the schematic from the schematic templates to Virtuoso, and back then imports certain Python definition of your schematic to certain locations. So it replaces that imported empty file with your actual schematic generator so that you can run it from your generator location. But this is kind of a mess under the hood. You don't need to know anything about it as long as it works. Currently it does. So it just makes writing these independent generators easier. And it has less than 1,000 lines of code, so it's not a huge effort to, or it was not a huge effort to construct, but it's relatively handy. Okay, so I have gone all the structure of this Virtuoso Template now, do you still have, or do you have more interesting questions that I could probably answer or elaborate the structure for you? If not, then it's Mirjana's turn to show actually how this thing works.
Can you give me a sec? My battery went flat. I didn't notice that I was connected, so I'm connecting to it. So can you start with the questions until I connect to the remote service? Sorry.
Sure. So if there are any questions, I also I may apologize that I know that it's not the most interesting thing to go through a hierarchy of a project that has Git submodules, but anyway, I think this is the easiest way to explain what is there and how they are organized and what is their relations and so forth. So then the next step, if you want to try this, is just to pull and try to run it in your organization's environment. It's surprisingly easy.
Now, Marko, I appreciate you going through the details of the repository and showing relative to a simple example such as an inverter, how this is put together or orchestrated.
Thank you.
One common theme I keep hearing here is that it seems that cadence is a bottleneck for us in some ways, in terms of furthering open source development.
Mm-hmm.
Are there questions? I have to step back for a second from my front door. Sorry.
I do have a question, Marko. Is this process agnostic, right? Like, how are you loading a new PDK, or how are you managing?
Yeah, this is a good question. What I did in our university, I have tested this with 2 different process configurations, and you pull in this template, you do the trick for the source me file so that it takes your Virtuoso environment into use. That's of course like organization specific. Mm-hmm. And then you replace this bag technology definition with the bag technology definition that you want to use. And the generator runs without any problems. So and if you have, yeah.
How does the definition look like? Right, like, do you take in the DRC rules, or like how is it gonna switch from a FinFET to Skywater 130 or something like that?
That is a good question. Currently, you need to define all these parameters manually, or let's say I don't have any way to instruct you how to figure out this number. Yeah. I can just tell you what it means because of the NDAs of the processes. If you want to set this up, let's say TSMC 28, I probably have the setup for the process. I can't give it to you.
Got it.
I can't tell you any detail on the process.
Okay. So another question. So let's assume I have a platform where I have all these setup files for different technologies. So then if I port an inverter, it's going to follow up the same rules, or like, is it going to have a standard cell dimension, or is it just going to be an inverter functionality?
It will follow the rules given in these technology definition files. All the dimensions given in the Inverter Gen generator, they are relative. So basically, we give them as multiples of routing grid, which is process dependent, or multiples of minimum channel length, which is also like process dependent.
I think Mirjana is ready.
Yeah. Okay.
Hey,
so
thanks
Mirjana,
a lot.
go
Sorry.
ahead. I stopped sharing.
Yeah. Sorry, I was on German keyboard and didn't realize, and and I have this double identification everywhere, so it's kind of pain. Okay, so let me share my screen. Sorry, I will try not to cough if it is possible. Okay, so start from this Virtuoso template. I don't have, let's say, a flexible working environment. So basically, my IT provided me something like, this terminal where I can just clone,
So basically what I'm gonna do is, I'm just gonna get this Virtuoso template and then, pop it in. Really sorry about the coughing, but so if you see right now, of course, nothing is in its place. We're cloning then submodules.
Yeah, just a brief note, just not to be the cadence police, but like if the repository has any log files that have time in them, that could constitute benchmarking, and that's completely illegal according to academic licensing, of course. But just FYI, I'm sure everyone knows that, but just throwing it out there.
Well,
Oh, thank you for that. Thank you for the reminder. Go ahead, sorry.
Thank you. Okay, so I'm gonna go out and I'm gonna copy to my Okay, so I'm gonna move to another, because here basically I cannot do much. I'm gonna actually move to my working environment. So here you can see, all the files that, and let's say submodules that Mark already described. So because this is CDS FFmpeg technology, and we have certain scripts in Bash to enable it. What I do, I actually have a environment already scripts prepared, but I make them, so for, let's say, let me see, to be honest, I forgot. Yeah. Sorry, it's a bit slow. So to make, okay, then I source them. So I'm giving you the whole what you're gonna face when you start doing it. So basically, my licenses have been loaded and also the technology information. Now I will execute Marko script, and then the script will lead me through it what is necessary. If you've seen, already here, I prepared all these for this demonstration, so I will just copy the first one that it comes. Sorry. And then I will again source me just for you to see. So this is next one that is missing. So you go and you put it somewhere from, from your customization. And the next one pops up that is needed. Basically, you are guided through the whole procedure. So more or less you're set, but you just need to configure to make those. Make files. You launch Virtuoso. There is one thing that I didn't do, and that is I didn't check out the branch where we are. Let me check that. This is basically where we should be. So Marko, do you think that I should repeat anything? I think
Init submodules.
Mhm. But the problem is I'm not here where I can
Okay,
do
then
anything.
I think this branch is you have the versions. You can still run it. Let's see what happens.
Let's go. Yeah. Configure. Okay. So let's see if Mirjana will do the trick. Yeah.
It doesn't. You
Yeah,
have
it's
to,
not the right version. Yeah.
No.
Okay. So the options are the following. Let me remove this and repeat the procedure.
Mhm.
Mhm.
You can init the
I cannot do it.
submodules in your.
Yeah. Wait. And I'll go here. Basically, I need to go here. So git branch. So I'm here. Basically, I'm in Virtuoso Template, but this is, I don't see the,
Git pull.
yeah, git pull. Okay.
You are in.
I am in a wrong one. I'm actually, damn it.
We have a case
Sorry,
of demo
guys.
effect here. Sorry, guys.
Yeah. I'm sorry. I'm actually in the, okay. So let's go.
Take a deep breath and start from the beginning.
Yeah. Okay. So let me see like this.
I could share some of my espresso with you, but I'm not sure that would help.
Hey, no.
Is this in TSMC 28 or Skywater 130?
No. This one
130?
is, no, this is CDS FFmpT, basically this generic
Oh, the
FinFET
schematic.
technology.
Okay. Got it.
Okay, so let me go just briefly to technology definition.
Should be fine. I just today updated.
Okay, let's see. So let me see. I need to now try to read.
Did you init the submodules?
Not yet. I did it before, but now I need to do it. Yes. Okay.
No, they're up to date.
So it should be okay now.
Mm-hmm.
So the versions of the repos on the right, we init. Okay, sorry. So since you already saw, let's say most of it, let me see. Sorry, I'm going fast. So now I'm just wondering what is happening. It seems that I have. Yeah.
Can you run those scripts in that machine?
Wait, I need to check first. Okay, this is here. And then it could be. Yeah, it is where it should be. So if I source out to make.sh, it should be already done. Module command not found.
I think you should be in the other terminal.
Yeah, that's right. Okay.
So I think this is demonstrating
the
the
problem that
importance of the seamless Git access.
I know, but unfortunately, I cannot get it. Okay, so it's CSH. So again, let's say copy. It is CDS lib core. Yeah, it will lead us. Everybody are so quiet. Is anybody, Marko, beside two of us here?
No, we're here, just patiently watching and listening.
Thank you so much. Hey, I'm really sorry. You know, I tried so many times because
this is a work group and it's perfectly okay, right? I think it also helps exhibit challenges that we all face as engineers in life. So
no crossing fingers.
it's not an executive level sales presentation, shall we say?
Okay, yeah, otherwise. Okay, let's see. Hopefully we are there where we should be. Yes, it's working.
Looks good.
So basically, you know, before me executing this, it's ending, finished implemented schematic. So before me executing all this, you just had inverter templates. And that is basically what Marko said. It is in this specific, when you see, you know, you have these inverter templates, but basically the core of the generator, which means layout description in Python and schematic description in Python and sizing. Let me go. So basically sizing is kind of here where we have also the switch to distinguish between FinFET and bulk CMOS, because there is a different sizing for width. One is float, the other definitely has to be integer. And you can see here that in inverter generated layout is generated. So and I mean, it is just an inverter. And also, of course, schematic. Let me see. With dummies, I mean, very typical and same as for back, and symbol also, which you can see here. So at this point, you can clearly see we demonstrated a basic functionality of BAG. Like Marko said, we didn't want to go into DRC, LBS, because every let's say institution has its own customization. The main effort was spent basically to improve the documentation and separate the information such that it is no longer just in one YAML file, everything put together, but to have some logical, let's say, logical connected pieces. I would like to go take you there. So Marko already explained. So the idea, the next idea will be, let's say, layer parameters. What we give to Mosaic group members is basically kind of a homework so that they clone, execute, and come up, with the problems, but also to check these specific parameters and say, add, if they have something, some better description. And Marko, we should be telling them to do that into in back to, I think, technology templates, because the documentation is generated from these specific, let's say, from these specific files. So that is one thing that I believe we need to do. Kind of to make, if we cannot share the information, technology information specific and protected, what we can share is descriptions such that people can easier find and debug, find information in the technology that they are using. There is also at Silicon Austria Labs, we have some work going on about generic technology where these data should be in future kind of semi-automatic or automized, the input will be automized, but that is not the current status. What I wanted to mention here also is at the moment, if you see here, we just have, let's say, Inverter Gen. And it is basically just one of hopefully many generators that we will have. So at the moment at SAL, I'm finishing, basically I cleaned these templates and adapted for TSMC 28 nanometer technology. My goal is basically to change the project, adapt the project basically. More or less everything is set. I need to change this back to technology definition. And then I will share it with people, institutions that we have NDA with. BWRC is one of them, FAK in Villach is one of them, and Infineon is also one of them. After that, my plan is, because we had a tape out, let me see if I can move this. Yeah, we had a taped out last May. So this basically BAG amplifier final was submitted and shared. It's basically open source, and it contains a bunch of smaller generators that we will, at least some of them, because what I believe it is important is that we increase the number of small generators so that people can learn, practice, improve, combine. So that could be the first step. And then after that, to kind of work and provide an example for hierarchical organization of the generators, which I believe Marko already has something. So that will be all from my side. If you have some questions.
Yeah, we're just a couple minutes past the top of the hour. So if there's any closing questions, go ahead, comment.
I'm really sorry.
Oh, no, that's okay.
Yeah, thanks, Mirjana and Marko, for doing the demo. I was just wondering if you guys are planning to plug in some open source tools, and is there any plan for that in the future?
Well, this is, let's say, first of the actions that we are undertaking as part of Mosaic, but also as a boot camp that Silicon Austria Labs is organizing. And Jada will come in August, and he's already working on enabling his generators with Magic. So we will see if it's possible to, we need to start replacing step by step. So if it's possible to introduce magic, at this moment I need to see also with Infineon, because on their plate is basically the framework, the roof, above this specific Virtuoso template. How can, will some hooks be provided such that we can hook up some open source tools? In that sense, I already before contacted some of the let's say authors or of the two open source tools, asking if they are willing to contribute. In a sense, there is a goodwill, but we need to provide a hook such that they clearly understand what needs to be done.
So does it make sense to have Jado give a presentation here of what he's doing regarding open source?
Yeah, I'm sure it does. You just need to see with him, he has, I think, two students working on this, like sky water magic, trying to make it workable. But from what I know, it's still not kind of, clean.
I see.
So
And
maybe it will be good to ping him and then see with him when he's ready to give a presentation here.
yeah, that makes sense. Thanks, Mirjana. Any other questions, Rob, or anyone else?
No, not from my side. If you folks could, if you could share a pointer to the repository so we could, people could have a chance to look at it, that would be great. I'd appreciate it. I know I have access to it, but might be interested. Folks might just be interested to go through it.
Yeah, it's very simple, and yeah, I will put it in the chat.
Oh, thank you. No, I appreciate both of you coming today and updating us on where you are and all the work that's ongoing there. It looks quite interesting, and appreciate all the effort there.
Well, hopefully, people will test it. If you have any comments, anything that, how can we improve, please?
Yeah, there was actually one final question from my side. How many, I'm just curious, how many different members you have participating in this, in the Mosaic group, I guess is what I would call it, right?
But if you go to Mosaic group, you can see at the moment there are only 2 active members, which is Marko and me.
Okay.
Three. One of my students is actively contributing on this.
Yeah.
Okay.
So, but if you see, let's say Mosaic in the group information, there are a lot of people actually just hooked in that we invited. So some of them are, let's say, Thomas is actively working, and he also involved in the whole story. People or like the engineers who will be working on the framework. Some people you might also know, or they are, let's say, they are here as a guest to observe the situation. But what I'm also planning from our side, for instance, yesterday we have 2 new members. Next 2 are joining next month, to use basically this Virtuoso template as the ground where we can basically, as the initial steps, where many people who go in this arena can make initial steps together. Because it is, you can see, plug and play. If you don't miss the branch, it is very easy to execute. It is very easy to execute, and it's self-explanatory. It has quite good documentation. The technology information will be, much clearer that the current situation will be back to, and it will have more available generators, to plug it with. And it will give this, the strategy how to do hierarchical approach. So what I'm saying is basic things definitely will be solved. And in July, we're putting one more colleague, one of these 2 that I mentioned. He will be working on the small layout generators, because in my opinion, it is extremely important to raise the level of abstraction. in layout. Without that, people will be very much reluctant to script, everything. But if you give them at least, some procedures, some already very common, layout solutions, I think it will be easier to kind of adopt it.
No, that makes sense. Well, thank you so much, Mirjana and Marko, for coming today and describing the work that you've done. I really appreciate it. Looks like great progress.
Thank you.
Thanks.
Bye-bye.
All
Thanks,
right.
everyone.
Thank you, everybody. Appreciate your time.
Thank you. Bye-bye.
Bye-bye.